Hey everybody, welcome to Bill Sky the COBOL Guy, and in this video we're going to talk about arithmetic, mathematics in a COBOL program. There's a couple of different ways we're going to do it. We're also going to take a look at some intrinsic mathematical functions in COBOL, so let's get right to it. Now before we actually get down to the coding, I want to load up the GNU COBOL Programmer's Guide, and you're going to see why is because it's going to give you guidance as to how intrinsic functions are set up. Now we're not going to do intrinsic functions right away, but what I'm going to do is I'm going to go ahead and expand the functions section, go to intrinsic functions, and you can see all the different functions. So we're going to play around with absolute value. We're just going to do a couple of them just to show you an example, and then it's kind of up to you to learn all the other ones. Okay, so let's go ahead and create a new COBOL project. And I'm just going to call this one math. And let's go in and edit it. All right, now I really should change the program ID and everything and put in some comments as to what this program is going to do, but we're just going to leave it there for right now. And also the date that I created. So you need to update your comments. But let's just go ahead and put in some variables. So I'm going to just call this one comp1 var1. And let's put some underscores there just to make sure that we don't do anything with reserved words. Okay, and let's do a second one. And let's say comp1 var2. And let's put in an integer too. I'm going to say int var1. I'm going to call this one pick. Let's do a z7, 9. And you're going to see why. And if you're not sure what the Z7, 9 means, take a look at the defining data video that I've got because that'll help you out. Okay? And let's see what we've got here. Oh, I put semicolons. I'm thinking of Rust and C and C++. So there should be dots there, periods, and it compiled just fine. Okay, so let's do the long way of doing mathematics or arithmetic in COBOL. And what that is that's using the add, subtract, multiply, divide keywords. But there's also a keyword or syntax called compute, which is more like C and C++ and Java. But let's do the longhand ones first. So what I'm going to do is I'm going to display comp1 var1 value is, and we're just doing that just to print things out. And now let's do some math. So I'm going to say add 1 to comp1 var1, and then let's do the display again. So the add statement simply means add the source to the destination. I'm going to go ahead and make that and run it. And you can see that our comp1 var, and I said var2 there, I'm not sure why I said var2, it should be var1. But it says here comp1 var1 is 0, and then we added 1 to it, and then we got the comp1 var1. Now something else you could do is you could say add 1000 to comp1 var1, and you could say giving comp2 or comp1 var2. So what the giving does is it allows you to say, okay, I want to add something to a variable, but I want to store it in that variable. I want to put it into another variable. So let's go ahead and do the display there. Thank goodness for copy and paste. And let's take a look. And you can see that comp2 or comp1 var2 now has a value of 1001 because we added 1 to it, or we added 1000 to comp1 var1. So comp1 var1 had a value of 1. We added 1000 to it and said don't store it in comp1 var1, store it in comp1 var2, and then we displayed it and we can see the 1001. So pretty basic stuff there, pretty easy in fact. Let's go ahead and play around with subtract. I'm going to say subtract 1002 from comp1 var2 giving comp1 var1. And then let's display comp1 var1. I probably should have copied the other one, but that's okay. And let's run it. And you can see that the 1001, I subtracted 1002 from it, and we got a -1. So pretty basic stuff there. Now let's play around with multiplication and division. Multiplication and division can be a little bit different. I've noticed some compilers with multiplication and division, you always have to specify a giving, but let's play around with it. So I'm going to say, let's go ahead and multiply comp1 by, I don't know, let's multiply it by a -1. So I'm going to say multiply comp1 var1 by a -1. We get kind of a, well, did I actually type that in? Oh, I forgot in one. Okay, let's name the variable correctly. Let's type it in correctly. Okay, we get kind of a strange thing here. I'm not really sure why. I've not seen this before, but for some reason it's not looking at -1 as literal. However, if I specify the giving, it takes it, no problem. So let's go ahead and now display it. And it should now be a +1. So you can see it made it into a +1. I haven't figured out why GNU COBOL does that. I haven't even really tested it. I've always used the giving keyword just because even if it's giving it to putting it in the same place, I've always used that. I'm not sure why, but I have, and it seems to work out okay. So a little bit extra typing, but you know it works. So that's the multiply. Now something else you can do with the multiply, which I think is rather interesting, is you can do this thing called rounding. And what rounding, when you do a multiplication, you say rounded. What that does is it rounds it up to the nearest integer. So let's do something interesting here. I'm going to move into, let's move a value 123.4567 to comp1 var1. And then I'm going to say multiply comp1 var1 by, and let's say, well, let's make this a little bit more interesting. Let's make this 1, 2, 3, 4. So I'm going to say multiply by 2, giving comp1 var1. And then let's display it. And let's see what we get. Okay, so that's good, but what we're doing is we're multiplying a floating point, which is a comp1 var1 by 2, and putting it back into comp1 var1. Well, the rounding's not going to really help you, and we didn't actually put that in there. But what you want to do is you actually want to put this into your integer. We're going to put that into our integer. So we're going to, it's int var1 I created. So int var1, and then we're going to say, let's display our int var1. And let's run it. Okay, so it's 246. So that makes sense. I multiplied 123.1234 by 2. That gave us 246.24, whatever that multiplication is. Pretty easy. However, what if I put a 9 here? Or actually, let's not put a 9 there. Let's put a 4. So what that's going to do is that's going to give us 246.8468. Now with rounded, and actually let's do this first. Let's do this way so we can compare them. And let's put the 4 on the second one. And we're going to say rounded at the end of the multiplication, of the second multiplication. So what this will do is this will give us the same value that this multiplication gave us, 246, but it'll see this 0.4, that'll be multiplied by 2, which will be 0.8, and it should round it up. So let's see what happens. Okay, so we can see our 246 here, and 123 dot is still 246, but because this 0.4 multiplied by 2 is a 0.8, it rounds up by like adding 0.5 to it, and that gives us a 247. So that's what the rounded does. It'll round up. Now there's also something else in multiplication that could be a problem, and that is that you've overflowed the number, and that's mainly with integer multiplication. So what I'm going to do here, and let's take a look at the size of our integer. Well, it's a 7, 9. So what I'm going to do is I'm going to say move 1, 2, 3, 4, 5, 6, 7, 8 to comp1 var1. So I'm going to move a large number into there. And I'm going to say multiply comp1 var1 by 1, 2, 3, giving int var1. Now I know this is going to overflow, right? Because I've got 7 digits here, or 8 digits here. The maximum size of our destination is 8 digits. 7 plus 1 is 8. And I know it's going to overflow. So what I'm going to do is I'm going to say on size error display overflow, not on size error display int var1. And we're going to see the difference. We're going to see what happens here. So I'm going to save and build this, and I'm going to run it. Okay, so we got an overflow. Why did that overflow? Because I took the number 1, 2, 3, 4, 5, 6, 7, 8, which is from a comp1, which is a floating point, and it can hold that number. I tried to multiply that by 1, 2, 3, and I tried to store it in an 8-digit integer variable. And there's no way. That's going to add 2 more powers of 10 to that, or I should say decimal points, integer decimal points, and so we got an overflow. So let's go ahead now and just change that one. And actually, I like to do things so you can see the difference. So instead of multiplying it by 1, 2, 3, let's just multiply it by 2. Now, will that overflow? Well, this is 8 digits. Multiplying that by 2 will just give us like a 2, 4. So it shouldn't. It shouldn't give us another tens position. And let's see what we get now. And, oh, oh, I'm displaying int var. Let's do this. Oh, I just displayed the text. I need to display the variable. All right, here we go. So the first one gave us an overflow because we went past the number of digits that pick Z7V9 or Z79 could store. But on the second one, we didn't. So it's almost like a try-catch. It's built into the multiply statement. So that's pretty cool, actually. I like doing that. Okay, so we took a look at giving. We took a look at on size error. We even took a look at rounded. These are all things that you can do. And remember, rounded is mainly for integer destinations if you want to send it to an integer destinations. And that's multiply. And we also looked at on size error and not on size error. Now, the next thing I want to talk about is I want to talk about division. And division is quite a bit like multiplication, and we're always going to use giving. For some reason, the compiler, I don't know why it's doing that. So let's go and divide it. So let's take this large number in our comp1. So I'm going to say divide comp1 var1 by 10, giving comp1 var2. And then let's display comp1 var2. Okay, so it's 1, 2, 3, 4, 5, 6, 7.8. Now, if you remember, comp1 var1 was 1, 2, 3, 4, 5, 6, 7, 8. So we simply divided that by 10, and now we've got that decimal point. Okay, so there's also another format of the divide statement, and that is the into clause in there. So I can say divide comp1 var1, and actually divide the divisor 100 into comp1 var1. And in this format, you don't have to specify giving. So let's go ahead and copy and paste that. Let's build and run it. And you can see that we have 1, 2, 3, 4, 5, 6, 7, 8. So we took 1, 2, 3, 4, 5, 6, 7, 8, divided it by 100 in this case, and now we got 1, 2, 3, 4, 5, 6.78. So that's actually kind of neat. Now, what if you have a remainder? What if you're dividing a number, an integer? Let's go ahead and do that. So what I'm going to do is I'm going to say move 1, 2, 3, 4, 5. Okay. To int var1, and I'm going to say divide 10 into int var1 giving int var1, and I'm going to say remainder. We need another variable for the remainder, so let's go ahead and create an int var2. Keep that real simple. And let's put the remainder on the next line. Let's save and build this. Now I haven't displayed anything, so let's go ahead and do a couple of displays here. And then let's do the same with int var2. And let's see how things work. All right, so let's see what we've got here. All right, so I moved 1, 2, 3, 4, 5 into int var1. I then divided 10 into int var1, giving int var1, which now has 1, 2, 3, 4 in it. Remember, it was 1, 2, 3, 4, 5 divided by 10. We're going to lose that. It's going to be a fractional portion. And I said put the remainder into int var2. I went ahead and printed that, and the remainder is 5. So it's kind of nice. It's really kind of a neat feature there to be able to do that. Now you can also do on size error and not on size error. So if you divide something and it's too small, or you have a rounding, not a rounding issue, but you have an overflow or underflow issue, you can also use this on size error just like we did in multiply. I'm not going to do it here, but you can actually do that. And a lot of companies, when you're coding in COBOL, they always want you to have an on size or a not on size, because they want you to be able to capture that just in case that problem were to happen. And you never know when that's going to happen. So that's always a good idea to do that. Okay, so the last thing I want to talk about now is the shorthand way of doing all of this, which is more like C or C++ or Java or Python as well, and that's using the compute statement. Now, the way that the compute statement works is that you specify an equation, but you have to specify, with the destination and the equation on the right, everything always goes from right to left, but then you have to put the compute statement in between, or at the beginning. So let's do that. So I'm going to just simply say compute. For some reason I always put computer. Compute comp1 var1 is equal to comp1 var1 multiplied by comp1 var2, and parentheses come into play as well, divided by 20. We could also then say on size error display overflow, not on size error display comp1 var1. Now, the size issue isn't going to be one when it comes to floating points. You really want to do that with integers, but I wanted to show you kind of the general format of how that works. So again, you wouldn't never have that, but let's go ahead and now let's print out the value that was computed. Let's build this. Oh, ont. What is ont? There we go. And it ran. We didn't have any overflow or underflow problems simply because it's floating point. What I could do is I could have done something like this. And instead of comp1 var1, I could say int and when you're doing integer work, it's going to work. Or the on size or not on size might work. It depends upon the result, right? I don't know if we're going to have a overflow or underflow here, but let's take a look. We could force it. So let's go ahead and change it a little bit. Let's get rid of the z's over here, and let's just make this 9-8. And we might see a difference. It depends upon the compiler, right? Now what we're going to get here is some of our output will look quite a bit different, because if you remember, a z is a zero suppression. So let's see if it'll compile this time. And it did compile. So because we got rid of those z's, they're all 9s, it's a real numeric value. But when we run it, you're going to see a lot of zeros in front of all of our results. Now we haven't been able to get an overflow here simply because, well, I don't know. So let's force an overflow here. I'm going to move 1, 2, 3, and it's 8, right? So 1, 2, 3, 4, 5, 6, 7, 8 to int var1. I'm going to move 1000 to int var2. And even though we're dividing by 20 over here, it still should give us an overflow. And it did. We got an overflow because it's just the product, the multiplication, even though we divide it by 20, the multiplication is too much. Okay, so now let's talk about intrinsic functions. Intrinsic functions, I think, are very interesting. There's a number of functions in COBOL, and what you can do is you can use those functions to do some special things like, you know, getting the square root and stuff like that. So let's play around with those intrinsic functions. Now, if you remember at the beginning, I brought up the user's guide for GNU COBOL, and you've got all, and I looked at functions, intrinsic functions. I looked at all these different functions. So let's go ahead and get the absolute value of some number. Now, if I'm not, well, we can just go ahead and move it in there. So what I'm going to do is I'm going to move -1, 2, 3 to int var1, and I'm going to say display absolute value of int var1. And let's make it a little more interesting. And let's see what happens when we build this. We get an error. It doesn't, I'm not really sure what the error is here. It's kind of a strange error. The problem here is that you have to put the word function. I know, it's a horrible pain in the neck, but you have to put the word function in front of the intrinsic function. And, oh, interesting. So we still have an issue here. Did I put a period there, or did I put a... Oh, I think I need a comma here. Let's see. Okay, what's happened here is we've gone past the end of the line. So I'm going to go ahead and put that on the next line. Now let's take away the function. Let's make sure you see that error. I'm going to take away the word function. I had a comma error on the first error. And you can see ABS is not defined. It doesn't know what ABS is. So if you put function in front of it, that basically means it's an intrinsic function. I want to run it. And now let's do that. And you can see the number -123, the absolute value is 123. And again, if you wonder why we've got zeros there, it's because we didn't put z's in front of the 9s. And so it's now going to be printing out even the zeros. So that's how to do that. We can also do something like, I don't know, there's sine and cosine. So, but before we do that, how can we get rid of this right here? Well, what we can do is we can go up to the configuration section, and this will be for the whole program. We can go up to the configuration section, and we can say repository. And from there, I can say function all intrinsic. And what that means is it means to make all the intrinsic functions available without having to say the word function. And so I'm going to come down here. I'm going to get rid of the word function. And now it should build okay. There you go. Now, there's another way you can do that. Let's say you don't want to include all of the intrinsic functions in your program. Instead of specifying all, I'm going to say ABS. I'm going to, let's say we want to do another one. Let's say we want to do sine. So there's another intrinsic function called sine. What would be another good one? Maybe square root. Maybe that would be another good one. Or maybe pi. There's another function called pi. And we're going to make all those intrinsic. So you can specify only the ones you're going to use. Now, I haven't done any research to see whether or not, and I have to get rid of those periods. I haven't done any research to see whether or not your program will be bigger if you say all intrinsic or if you just specify those the three that you're going to use. I've always used all, but I've never done that research to see if the program will be bigger if you say all. My first thought is it might. My second thought is I don't think it will be, but again, I haven't done the research. So now I can do all of that with those intrinsic functions. I do not have to specify the actual word function in front of it. So let's do some interesting things. I don't know. Let's create a variable up here because I want to mess around with sine, geometric functions. So I'm going to create a variable called radians var. And that's going to be usage is comp1, value 0. So radians var. And now the reason why I created that variable called radians var is because all of the trigonometric functions in the intrinsic function list in COBOL, they all based on radians. They're not based on degrees. So what I want to do is, let's say if I want to get the sine of 90 degrees, and I don't want to have to remember how to do that in my head. What I'll do is I'll say compute radians var equals the degrees that I want to convert to radians multiplied by the intrinsic function pi. Notice I don't have the open and close parentheses. Let's leave that there for right now. And I'm going to say divide by 180. So let's see what happens when I build this. In this case, it worked. I have seen compilers where if you have a function that doesn't take any arguments, if you specify the parentheses, it won't compile. But in this case, in GNU COBOL, it does. If I take away those parentheses, it's almost like a constant. So there's our compute radians var. Now, if I didn't put pi as an intrinsic, I would have to do this. Up in the configuration section, I'd have to put the word function in front. Now, even though I did put it up in there, I can still put the word function in front. It depends upon what you want. I've always liked putting the word function in front because it's kind of like a self-documenting. That's an intrinsic function. I kind of wish they would have called that intrinsic instead of function, or maybe I function or something like that to better define it. Okay, so let's go ahead and let's calculate the value of sine. So I'm going to say, now let's do this with the move. So I'm going to say move the sine of radians var 2, and I believe it was comp 1 var 1. And I'm going to say display the sine of 90 degrees is comp 1 var 1. And we can see that it's 1. So you can do that with, you can execute this function and then move the resultant value this way. You can see right here we can run a function, an intrinsic function within our compute statement. You can even do it in a multiply. So there's all kinds of, I would say probably the most common way of doing it would be to use the compute. Okay, so there's one last thing I would like to go over. It has a little bit to do with formatting of output. If you notice, we've got a lot of this stuff kind of stuck together. What if I wanted to print a new line right here before the display? Well, there's one way I could do it. I could simply say display, and that'll print a new line. Let's go ahead and take a look at that. Oh, look at that. It doesn't. Let me put the period there. Maybe that's the problem. Nope, that wasn't the problem. Let's put a space there. That might do it. Okay, good. So if I go ahead and run this now, we have a blank line here where there wasn't a blank line before the sign. Now it would be kind of nice. Wouldn't it be nice if they had an endl or a \n? Well, the problem is that they don't have that in COBOL. It doesn't know what a \n is. So you can't really do that. So what I'm going to do is I'm going to actually create a variable called CRLF, and we can use that anytime we want in our displays. So let's go up here to the top, and I'm going to make this into a constant. So I'll go ahead and put my constants before my normal variables. And I'm just going to call this CRLF. And from with here, I'm just going to say value hexadecimal, which is the x, 0D0A. Let's go ahead and save and build that. I might need to put the capital D and the capital A. Let's see if that works. Okay, what am I doing wrong here? Oh, 89. I meant 78. All right, there we go. So now my numbering is all off. I like to do that, so I'm going to say build custom renumber, and then file reload. Okay. So now what is the 0D0A? Well, if you take a look at the ASCII table, and let's actually do that. I'm going to go to ASCIItable.com, and if you look at the ASCII table, let's take a look at 0D0, and let's zoom in a little bit here. So we're looking at hexadecimal D. That means carriage return. That's like on an old typewriter, move the line up one. What is 0A? That means line feed, go to the beginning of that line. So 0D means go to the next line, 0A means go to the beginning of that next line. So that's what we're doing here. So we're going to create a hexadecimal value 0D0A called CRLF. And now instead of having to print this display like this, I'm just going to put CRLF, comma. and it gave us that blank line there. So that's just kind of a little hint of what you can do to actually create an endl or a \n that you can put anywhere in your code. Now you can't put it here because that's inside of a string, and it won't grab that variable value. It'll just print CRLF. So that won't work. But for something like this, or if you want to do something like a double space after the display, you could do a CRLF at the end. Let's make sure that builds okay. And notice there's no blank line after this. Now when we run it, there's a blank line after it. So there you go. So that shows you a little hint on how you can do that. Okay, so that is simple mathematics in COBOL. We use GNU COBOL. A lot of the same thing still works in IBM COBOL, Micro Focus COBOL, even Microsoft COBOL, that really old COBOL from back in the 80s. So I hope that helped you out with math in COBOL. Hope to see you soon.